Should come up. Okay, and we're live. Hey, hi everyone, and welcome to this Festive Tech live session, the Festive Tech Calendar 2021. Today we have Jan Vidar Elven. Jan Vidar is from Norway, and he's an enterprise mobility Microsoft MVP. Hopefully, I got that right.
Yeah, that's right.
I'm going to Jan Vidar Elven. I'm going to Jan Vidar is from Norway, and I'm just going to drop out of this and leave you to it. So the floor is yours, Jan Vidar. I'm here if you need me. So yeah, I'll leave you to it.
Thank you, Gregor. So let's get started. We are going to talk about something called creating an Azure AD Protected API in Azure in just a school hour. Sorry for the little delay about the stream if you were waiting, but now we are ready to rock and roll. So my name is Jan Vidar Elven. As Gregor said, I'm coming from Norway. I work in a company called Skill. I'm an enterprise mobility. I work a lot with identity and access management. And also most of my work these days are based in and or around Azure. So my idea for today was to talk a little bit about how we can create an API in Azure that we can protect with Azure AD. So this will be very few slides and most about the demos, and I think people generally love that. So I hope you enjoy this session as well. So let's get started. First of all, I just want to introduce the concept of APIs and what we call RESTful APIs. So APIs is an application programming interface. It's something that a client, a website, for example, can talk to, and then you can do some logic processing. You can hide some security and connections that the website doesn't need to know about. And you can do different kinds of methods or processing based on the needs of the users, clients, for example, the website. And often behind an API, you have some other components, for example, a database. So if you have a connection string to the database, it makes sense to hide that connection string so that you don't have connection strings directly into the websites, for example. So this is the main topic I will broaden about today, because I have built an example using just that, a website that use APIs to talk to a backend database. In my case, the database is a Cosmos DB. So I have created a database in Azure where I store items in a database that we will talk a little bit about later. But the API is the interface that will talk to the database, creating, deleting, editing, and so on. The website will talk to the API, and then we can have a flow where the clients can go into the website, talk to the API without knowing any logic behind it, and the database will be updated accordingly. So in my case, I've just built on a Microsoft sample. You can think about a products database sample. So I've just modified that a little bit and created a Christmas wish sample. So basically, my website is about registering your wishes for Christmas. So you can create, I wish this, I wish that, and then you can send that into the database. And you can change your existing wishes or delete them if you want to do that. The security part about this is that how can we make sure that the connections from the website to the API is secured? And for that, we will use Azure AD. So by Azure AD authentication, we can get a secure token to the API. We can identify ourselves, and we can also make a connection between who has registered what and what kind of wishes do you want to see. So all that we will get into a little bit later in the demo, but that's the main concepts of this presentation. The resources I want to point you to, and you will have those links. I can put those links beside that YouTube window later, but it's a blog post. This is published now today, earlier before the session, where I walk through the steps behind the API building, and how this is set up, and how you can configure and work with this sample yourself. And I have built the code samples in my repository at GitHub, so there's also a link there. And generally, you can reach out to me on Twitter, LinkedIn, and other social media using Jan Vidar Elven, and you should be able to reach out if there are something you wonder about after this session. So these are the resources that I will provide and also walk through now. So let's get started. So I will go out of the presentation now because we are out of presentation mode and going into demo mode. First of all, let's have a quick look at just this repository. So in this repository, I have created some folders. I have a Visual Studio Code workspace file, and I have pre-created a lot of the APIs in a separate folder, which we will go into in a short time. And I have the web components, an HTML file, and some JavaScript. This is a Node-based single-page application. And I also have some demo steps documented, and I will get into that later. And also I have some helping commands for setting up a database, for example. These are not finished, completed yet, but I will update them after a while. So, but you can create those directly in the portal as well. So this is the starting point of the sample, and you can download this as a zip file or do a fork or clone and work with this yourself if you want to. The other part is the let's see, the blog post. I'll show you that quickly. So this is the walkthrough where I talk about how you can set all this up, and I will refer to that repository. So I will talk a little bit more about what is an API, what constructs as a RESTful API, and so on. Let me see if I can just make this a little bit bigger. So basically, APIs, they should be RESTful, meaning that we can use HTTP as the application protocol, and also focus on the use of resources. So for example, a good example of a well-known API is the Microsoft Graph, where you have the API URL, and also you have a version, and then you focus, for example, on users. That's a resource. And you can also go into specific users by ID, for example. You are using HTTP verbs for getting data, posting is for creating, put for changing. You can also use patch for replacing something, and then you can also use delete for deleting something. So RESTful APIs use those HTTP verbs. And also another thing to note is REST APIs are stateless, in that requests can be run independently of each other, and you can also make sure that you don't store anything that the next request or another request can access or should have access to. So these are the main guiding principles, and then you can use Azure to create your own APIs. And for creating APIs in Azure, you can do that in a lot of different ways. You can, for example, you can use app services. You can build your own API using development technologies. You can use a compute platform and build your APIs from there. But you also, in Azure, you have also those serverless technologies that makes it easier to get started building APIs. For example, Azure Functions or Logic Apps are two examples of serverless technologies that have HTTP requests and responses and can be used as APIs as well. So in my solution, I will use Azure Functions for that API scenario. So we can create a serverless API that will receive and respond to HTTP requests. So the demo scenario I will show you today is a Cosmos DB account and database, which will store those wishes as document items. I talked about earlier that we are building a sample where I can register my wishes for Christmas, and other people can do that as well. An Azure Function app that will serve as the API. And that function app will have the methods to get wishes, create new wishes via post, change existing via put, and delete wishes. And also, that function will provide a secure connection to the Cosmos DB account to update those items accordingly. I will also have an Azure App Service running the website as a front-end web app. That's the client, from where users will get those methods exposed. Just a table and something to serve as a user interface that will call the functions API. So back again to the diagram. This is the simple idea. So we implement all the logic in the API. We have a database, Cosmos DB, as the backend, and we are using a simple single-page application website using Node and JS JavaScript for the processing elements. So there are no backend resources to the websites. Everything happens in the browser, and that's another idea and reason to hide the logic and security in an API. So tools, what tools do you need? Obviously, you need Visual Studio Code. You can work with some of these samples using normal Visual Studio installed client as well, or maybe others development solutions. But in my case, I'm working with Visual Studio Code. You need to have Node.js installed to work with the database, the website. You need Azure Function Core tools to be able to work with Azure Functions in Visual Studio Code, and you need the Azure Function extension together with the Azure Account extension, so you can log on to and work with Azure Functions directly in Visual Studio Code. My language in the API will be PowerShell Core. You can have any kind of language for the API. It could be C#, it could be TypeScript, and several other solutions, but I'm running PowerShell Core. So you might have that installed as well if you want to work with this locally. You also need access to an Azure AD tenant where you can create app registrations for Azure AD authentication. And you need an Azure subscription where you can actually create those required resources. On that note, let's go into let's see here. I'm just going to, so I will go over to my demo environment, and you will get a quick look there. So I have created a resource group, which I have called Festive Tech Calendar. Here we are. And in that resource group, I have some resources. Those I have pre-created. I have an Azure Cosmos DB account. I have an app service for serving the web frontend. I have a function app that also have created a storage account. And I have some application insights or some application plans. So basically, these are the resources I need. And those can be run on either a free use or a low-cost development use based on your scenario. If you want to use something in production, you might have to have a different plan, of course. So these are the components I already have in my Azure, created before I built the sample. Let's go into Visual Studio Code. So let's see. If I first of all make sure that I have a little bit larger text so it's easier for you to follow along. That's a bit large, maybe. One step down. So in my repository, I am cloned it locally, and I have my repository from here. I also have a workspace file. So let's go into that workspace file. Open workspace from file. And inside that workspace file, I have, if I open that, and then I can just clean up some previous open files to make it a little bit cleaner. Let's see here. All right. So basically in the workspace file, I'm working with two main folders, and that's the API and that's the frontend. The API consists of a Visual Studio Azure Functions project, which I have already set up, and this is already checked into the repository, so you can have that as a starting point as well. So the API, I have something called the different functions here. I have a create wish function, I have a delete wish function, get wishes, and update wishes. And I also have some settings that you automatically also get when you start an Azure Functions project. In the front-end folder, I have just an image, I have an index HTML file, and I'm also using an index JavaScript file for some of the logic. So if I go into, now I'm already placed with my, I already have a terminal session inside the API folder. So if I go into my Azure extension here, you can see that I can sign in with my Azure account. I'm already signed into my Microsoft Azure sponsorship subscription, and you will need to be signed into your subscription here. And under functions, it's just refreshing now. Here I have the possibility to create a new project, something I already have done from before, but if you're starting blank, you can start a new project in your API folder, and then you can create functions directly. So basically, if you are running, creating a new, I want to have a new function, you can just click on create function, and it will say, okay, which folder do you want a new function? Okay, I want it in the API folder. I want to have an HTTP trigger, and I can call it, let's just have a demo now. I will call it HTTP trigger 1. And I just press enter. And then I will have, what kind of authorization level do I want to have? So basically, often you will have a function authorization level because you need to have some secret code that the callers need to know before they can trigger your function. But today we will go into how we can protect that Azure Function app using Azure AD. So then I can use anonymous because I have an authentication layer on top of the function app. So I will select anonymous now. So what happens when you create a new function? You can create, you will have a default, some request, getting the input request, some data will be shown here for if there have been a request body or a query that has a parameter called name, it will report on that back to the user. So that's a simple start of getting an Azure Function project. So what happens when you create a new function? It basically creates a new folder like this. And inside that folder, you have the run PS1. That's the actual processing. And then you have the settings for the function in the function JSON. And here we can have change the authentication level. I selected anonymous, but I can go back and select, for example, function. What kind of trigger is that? And so on. And then you can see it implements some default methods like get or post. So basically, when you are running a project, after you have created a new function, you can just click func start. That will start the API locally on your computer. So let's see here. So what you can see now is that if I go, yeah, here it is. So you can see that my functions, create wish, delete wish, get wishes, the new HTTP trigger, and so on, they are now running at localhost 7071, and they are running under the subfolder API and the name of the function. And this is not a good practice because all of those methods are now supporting get or post, and they have different names under the API. So one of the things you want to do if you create a RESTful API is that you want to have a consistent naming for resources and also use the correct verbs for the different operations. So let's do that first of all. So I just exit this process now. Here we are. And I will just delete that HTTP trigger. I don't need it anymore. And then I can go into the different functions. So let's start with create wish. So creating a wish should be a post operation method. That means that when we create a wish, we will do that with a post request. And also, we will implement something called root. And root is something that we are saying that the API should send requests to. So as you saw when I started the API locally, I had different routes for create wish, update wish, delete wish, and get wishes, and so on. I don't want that. I do want that every request should go to a wish resource. And I can also implement parameters. I don't need that on create, but I can just click save now, and then I have a type of different route. So if I go to delete wish, here we are. So I will change the HTTP verb again. So I will do a delete. And once again, specify root be wish. This time, I also want to use an ID. I want to have the ID of the wish I want to delete specifically specified as part of the API, like this. So let's copy this line because I will want to reuse it. And then we have get wishes. So in get wishes, I will have also now then get command, but I don't need post. I only want to have get. And I will specify a route again. And this time, let's see, I need a comma here. And this time I want that ID to be optional. That means that if I don't specify an ID, I will get all the wishes. But if I specify a specific ID, then I will get only that wish. And let's go to the update wish. And update wish, it will use the verb put. And I will have that with a wish ID as well. And that's not optional. I need to specify an ID to be able to update an existing wish. So these are the changes I want to implement. So if I now click func start, Now it's looking much better. So now we can see that the API is now focused on the wish resource all the way. It's consistent. I'm working with wish as a resource. And the create, delete, get, and update are using the different verbs accordingly. And for delete, I must specify an ID. For get, I can have an optional ID for getting a single wish or getting all. And for update, I have the specific ID. So this is the first part that you would look into for making your API RESTful. So with that, we have that in place. In addition to the input binding, which is coming from the HTTP trigger, I also have an HTTP response. That's also part of making APIs RESTful, that you can respond with, for example, a JSON object or maybe another type of response. I have also added some Cosmos DB input and output bindings. So I have an input for Cosmos and output bindings. These are directly supported bindings you can use for creating and updating Cosmos DB items. All you need is a connection string and specify a name of the database and a name of a document collection. So this is based on my actual created Cosmos DB in Azure. And under local settings, I do have a Festive Cosmos DB connection string, and that connection string you will get from your Azure database. You can go in and read out the connection strings with the keys and everything. So you need that, and you can refer to that in the bindings. So this is brilliant, because then we can let's see again. If I go back to the function here, I can reuse that connection when I want to do some logic. So for example, for update wish, so this is something I pre-created, and a big kudos to Barbara Forbes as well, because I have also linked that in my blog post, because I have read about how she did this in a separate blog post, and I have linked to that in my blog post. So these are good examples on how you can get, for example, I'm getting the ID as a parameter from the wish, and then I use the Cosmos input, which will list all those Cosmos items, and then just filter that list to be the specific ID. And then I can update, for example, the name or the what kind of wish it was, and push that back to Cosmos output. That's all you need to do to be able to update data in a Cosmos database. Get data via the input and push data back. So it's quite simple using the bindings. You can also do that under get. You can do getting all the, if I have a specific ID, I will get only that ID. See, here we are. And if not, I've just specified wish as a resource, and I will get all wishes, and then I will just receive all of them. And you can do some logic here, and you can push that back as a response. So how does this really work? Because I have started those processes now. So let's go into my, I have a Postman client. Postman is really great for testing and evaluating your APIs, specifically when you work with them locally, because then you can have really do some good testing. So here we are in just a minute. So I work a lot with Postman when I do different stuff against Microsoft Graph and other APIs, but I have created a separate collection for my Festive tech calendar requests. Let's see, here we are. So I have saved some queries from my request. And if I go to get wishes, for example, you can see that I go to HTTP localhost 7071 API and wish. And if I click send here, it should return from the Cosmos DB database all my wishes. So I have created some wishes historically here and returned it as a JSON response. And likewise, I can go and delete wishes by an ID. I can update by ID. And you can see that from get wishes, I returned an ID. So this is the ID I want to use. For example, if I want to do an update, I will use that ID, and then I will just change. Okay, what is my wish, or change my name if I had a typo, for example, something like that. And by create wish, I can supply and create a unique ID using a GUID, and just select to, for example, Jan Vidar. I have a pronoun, I will show that later. And then I can say that, okay, this is today, so I want to make a new wish for snow to Christmas. Let's say white Christmas. I do love a white Christmas. And then let's update the date today and use, for example, it's 12:39. If I do a post here, send this, I will have that back here. I did got a response back. And also I can do some debugging, because everything that happens to my I will just change a little bit down in the layout so I can see it. So you can see every call that gets requests will be logged in the window here. So function create wish was programmatic call via the host APIs. So I can have some debugging information as well if I need to do that. So everything worked fine. So this is the first part about any type of testing with APIs. You need to have some method to actually go and trigger or test the APIs. For the remote ones, I have just specified the Azure Function App URL, but the path is the same. So creating or updating and so on, but I've just, instead of using localhost, I'm using the Azure Websites Function App. Okay, so that's Postman testing. And now we can go over and look at the, let's see here, the front end part. So the front end is just an HTML file. So I can, this is a sample I've built on from Microsoft. So I'm not really a web developer, but I have managed to change some text and some visual layouts on it, and using a photo and so on. So this is just a built-on example from Microsoft, but this is the actual website. I will show you that in a minute. And it's using a JavaScript where I have a constant for the API. And this, in this case, it's 127.0.0.1 localhost, 7071 port, and API. So I'm just using that as a constant to work locally for now. And then there are some technicalities. I'm using something called Vue and Axios for working with the API. So this is something that the JavaScript developers might be familiar with. But basically, you will see here that I have get API wish, I have put for changing update wish, and so on. So basically, you can just, even though you're not a JavaScript developer, you can basically go in and change some of the addresses here and some of the parameters you need to use. So this is the actual website. So if I go into another terminal window where I will, let's see if I'm in the correct place. I have some previous session here. If I go into Frontend, the Frontend folder, I can do an npm, right? npm start. And that will actually start the website locally on my computer. There we are. So now I have an HTTP localhost 3000. And if I go and select that address, and I can now go, for example, to, let's see if I can go around here and click new and just paste that there. So this is the website. So it's basically a picture with some snow, and actually now it has hit the get wish local API endpoint, and you can see that all my wishes are showing here. So I can go in and update them. I can delete wishes and so on. I can do some testing, updating some values if I want to do that. The White Christmas one was shown here, as you can see. So this is basically the wish list, and everything that happens behind the scene here is going through the API. Great. So that's the starting sample, and basically you will get this sample up and running yourself if you copy the repository and follow the steps in my blog post. But now, how can we make and create a security around the API? So I will close that now, and I will go back to my Azure subscription. So for creating security and protecting your API, you need to have some app registrations. At least one, but often I create a separate app registration for the API definitions, and then I use a client app registration for example, the web frontend, or what kind of authentication platforms I'm going to use. So if I go into app registrations, and this is something that the blog post details, how you will create that in that yourself. But I have created two app registrations, one to represent the API and one to represent the frontend. So if I go to Festive Tech Calendar API, the first thing I do when I do that is to set up what kind of account types do I want to able to use. Often you will do from your own tenant only, but then the users have to be in your tenant or maybe guests to be able to authenticate. In some cases, you want to create a multi-tenant authentication provider. So in this case, I'm just done just that. I've created a multi-tenant and personal Microsoft account, supported account types. The next thing I did was that I went to expose an API. So, and first of all, you will have to be setting an application ID URI here. It could be the app ID, but you can also create your own text here. So I have created API : / and Festive Tech Calendar API. So this is my app ID URI. And then I can create scopes. And scopes are important for, these are the delegated permissions that your users can request, and the website will request on behalf of the user to be able to go to the API. So for example, if I go and click add the scope, I can say I can also focus on the resource here, because I can say that wish read. So, and users can consent. And app can read all wishes on behalf of signed in user. So I can also have that as a description. I can also have a separate user consent display name if I want to do that, and I can then click enabled. So basically this means that I can now have different kinds of permissions for the permissions I want to implement in the API. So one thing is authentication, but the other thing is authorization. By using authorization logic, you can check what kind of scopes the users are signing in with, and then you can have different logic. For example, does it make sense that everybody that logs in should be able to see everybody else's Christmas wishes? No. So maybe you should have some authorization logic that users that sign in, they should be able only to see their own wishes and not everybody else's. For example, you can do that with wish read. And if users are going to be able to write and change or delete their own wishes, you want to give them wish read write. And for example, you can also have a read write all, and that is something that only privileged users are allowed to consent to, for example, by specifying admins only. Let's say that Santa Claus, he's a privileged user. He should be able to see everyone's wishes and change them or delete them if they have been naughty, but everybody else should not have that permission, because then they will be able to change or see everybody else's wishes as well. For example, you can have that kind of logic. Often, if you don't have those specific resource-based scopes or permissions, you can also implement something called user impersonation or access as user. These are more general permissions to be able to access the API in general, but not to be able to work with the resources, for example. So there are different ways to approach this, but basically you need to have those permissions exposed. After I have done that, I will go and create a separate app registration, and this is for the web client, for the front end. So I will go into API permissions, and then if I want to let the API use permissions from the front end to use permissions from the API, I can go and add, and usually here you will add Microsoft Graph permissions if you're working with Graph and so on, but you can use also my APIs. And then I have the Festive Tech Calendar API, and then you can go delegate permissions, and then you can see all the other permissions. For example, like the newly one created wish read. So add that permission. Here we are. So now we also have that added to the possible permissions for the front end. So usually I don't select grant admin consent here if I want users to be able to consent themselves. But if I have admin rights like wish read write all, and then I click grant admin consent here, then everybody also will be granted read and write all users' Christmas wishes. So I don't want to do that. You can do specific grants for some admin permissions via constructing a URL and do that, for example, via a button that is hidden from other users, but I won't go into that scenario now. So basically, this is the first part. You are connecting the front end to the backend API with the permissions. And then you need to set up an authentication platform. And usually here you will go and add the platform. For example, in my case, I'm using a browser client application, a single page application. So if I select that, I can specify a redirect URI, and then I can customize that platform. So I have already done that here. I have a single page application, localhost 3000, which is the JavaScript application I'm running locally now. And you can also select what kind of tokens do you want to issue. If the application has a single page architecture and doesn't use the authorization code flow, or if it invokes a web API via JavaScript, which is correct in my case, you need to select both access token and ID token. So I have done that. And then you can also see I'm supporting accounts in every organizational directory. There's a big if here. My web app is now hosted in the Elven tenant, and Elven users can now log in and consent to the permissions. Also, personal Microsoft account users can also log into that web application and consent to permissions there. But other Azure AD organizations cannot automatically consent to that application if that application is already approved by admins in your organization. That has changed also recently, because we do now have to have verified publisher for applications from other tenants. So users will no longer be able to grant consent to newly registered multi-tenant apps without verified publishers. So basically, if you're coming from another tenant, even though an application is multi-tenant now, you cannot consent as a user to that permissions, and you will get an error when you try to sign in. All right, so this is the authentication part. I'm also created a redirect URI for Postman, because I want to test the authentication platform in Postman, so I have added that as a web platform as well. So you can see that. I also created a secret, and that secret is for use for Postman. The single page architecture is not using secrets, it's using authorization code flow. So it doesn't have to have a secret somewhere hidden in the website, because that would be something that everybody could access. So we don't need that there, but we need it for Postman scenario. And also you see something called generated by app service here, and I will get back to that in a minute, because that's the link between the function app and this client. So that's the two app registrations you need. And then I can go back to my function app. And what you will do if you want to be able to require authentication to your tenant, to your function app, I mean, you will go to authentication, and let's see, here we are. And then you will have to, that's the wrong one, sorry, Festive Tech Calendar. There we are, sorry. So if I go to authentication, so I have cheated a little bit, I've already set it up. But basically you go in here and you click add provider. And then you select some provider. I've already selected Microsoft, but you can also select other providers to be able to sign into your function app. And then I will select require authentication. I will select that if you are getting users that don't have any authentication, they will get an 401 unauthorized. And then the identity provider that I added is connected to that app registration, Festive Tech Calendar Frontend. And the secret value inside that app registration, this provider here will automatically update and use that secret as an app setting for the function app. And here you can also see that when I do that, I can do what kind of issuer do I support. This is my own tenant ID. If I do want to support users from other tenants as well, I can change that to common, because in this case, with my personal Microsoft accounts and other tenants and so on, I want to support any kind of issuer for Microsoft identities. And this is also the most important part to not forget. I need to specify the allowed token audiences, because that means that when I get an access token using that front-end app registration, that access token is directed for the API. That's the app registration. So this is the app ID for that app registration if I'm using version 2 of tokens, access tokens. But version 1, they are using API : / and the name of the app ID URI. So there's a little difference there. But here I can also specify additional APIs if I have that. But now I only have that API. So this is the authentication part. Okay. That means if I go now to my function app, and I had the get wishes remote, And if I do no authentication and do a send request, I will get a 401 unauthorized response. You do not have permission to view this directory page. So voila, I have now protected my API. It has been protected by Azure AD. And if I want to connect to that API, I need an access token that actually can talk with via the frontend, but talk to the API. So if I go in and select inherit auth from parent and click send again, I still have 401 authorized. Okay, I do have a token here, but let's see, because I have parent, this is the name of the collection. And here you can see that I have set up in Postman how to request an OAuth2 authorization header. And I will have that as a bearer authorization header, given it a name. And then I have the specific settings in my case. So I'm using the callback URL for Postman, using the browser. That's why I added the web platform and that redirect URI. And then I'm using the common endpoint, as you can see here. And then I have a client ID. This is a variable that I have created and saved in my Postman environment. And I do have the same for the size secret. And for scopes, I'm specifying which kind of scopes are the user requesting. So access as a user and wish read write, for example. And now let's see if I'm in the correct, let's see here. Just starting up the right, my normal end user here. So I will go back to Postman and then I click get access token. So this was the wrong, sorry. I got the wrong session. This is the one. There we are. So I want to sign in with my Elven user because that's from where the app registration was created. All right. Everything was successfully. I do have already granted that. And then I get the authentication complete. So I can click proceed now or just wait a second. And then I'll get a new token. So if I click use token now, that token will be added. And I can click control copy. And then I will do a little check of that using the JodVT MS. So this is the access token I got. The audience is the app ID to the frontend, the Festive Tech Calendar API. And this is my issuer because I'm coming from that tenant. And this is my name and the scopes I have in my request. Perfect. And if I now go to Postman and do another check on get wishes and using inherit auth, oops, still unauthorized, but maybe I should be able to just save this first. Save it. Let's see. Let's go back and check a little bit. Could be that I need, because the version 2.0 formats are coming from microsoftonline.com endpoint and not from stswindows.net. Now it's looking better. Now it's processing the request. So I haven't run that function app for a while, so it will take a minute to get started. I'm running a consumption plan, so it goes to sleep from time to time. But now this, we're nearing the wrap up here, but there are some steps left. First of all, it will be now possible. So here we can see I got the request, and now I have been authenticated as well. Perfect. So what I can do inside those functions here, if I go back, I had an error from previously. Okay, so from those functions, I can do, for example, in get wishes, I can, after this first triggering of the function, I can go in and start constructing the authentication header. And then I can make decisions based on that. So for example, inside one of the resources you have in my GitHub repository, I do have some demo steps. And here you can see how you can add, for example, functions. So first of all, there are some requirements for PowerShell modules to use in Azure Functions. I have added something called JVT details, which lets you deconstruct and show the values of the token inside the Azure function. So you can make decisions based on that. I'm also using Azure PowerShell. So in by adding that, you will have that module implemented. And then you can add some code logic. So this is just samples. I have not implemented them into functions right now, but you can add that in the demo. So after you can get request header authorization, you can request authentication header, you can get the token details, and you can see who requested that request to the API. Is this the personal Microsoft account? Is it a work account from which tenant? And then you can also do some checks. So if the user doesn't have wish read write all, if the scope does not contain wish read write all, you're only authorized to see your own wishes. So I will just filtering down to your name's wishes, for example. So this is a practical example for how you can do that. And to be able to do that, you also need to, for example, if you want to filter by UPN or user ID, you can also do that. But then you also need to get those token details when you create documents in the database. So this is another sample how you can do that. So this is how you can do authorization logic by code inside the API as well. So what is left here is that this is part of the demo samples as well. So if I go into the open file, and you will see here that I have some files for authentication. So time has run a little bit from us here. So I won't show this in detail now. But here I have some authorization configs and so on, so that you can see that when, for example, I do I did a change to the JavaScript file, and then I can go in and get a token response and use that token response for every request as an authorization header against those requests I showed earlier here. So this way, the website will be able to communicate securely with the Azure function as well. So all these files will be available in the repository if you want to play around with that later. All right. So with that, I think I will finish up. Back to these resources. This blog post is showing more details about the things I've talked about today, and also in my GitHub repository, you have the starting points and some of the demo setups and extra resources if you want to implement that website yourself, for example. And if you have any questions or something you want to ask me about this, please reach out to me on LinkedIn or Twitter, or give me a follow there. So with that, thank you. Have a very happy Christmas, and see you around.
Thank you, Jan Vidar. That was excellent. Brilliant. Thanks very much.
Perfect.